This video will be the breakdown of the ordered or desired over have. This is actually a pretty basic formula to figure out your dosage calc, but it can be complicated if you start to use it for figuring out IV drip rates and different IV calculations. So if you have a really good understanding, you can work out IV problems with this method, but I would encourage you to watch the easy IV calculations video linked at the end of this math module. This first problem, we have an order for heparin, 3,000 units subcutaneously, 4 times a day. The information for our drug is on the label below. So the question is, how many mils of heparin would the nurse draw up in the syringe? And you can pause it right here if you would like to try to work this out before I show you how to work it out. Our ordered amount is 3,000 units. What we have available is 5,000 units, and that is in a concentration or quantity of 0.5 mils. Another way that you may see this is a volume of 0.5 mils. So that will translate to taking 3,000 mils are ordered over 5,000 mils are have and multiplying it by our quantity or volume of 0.5 mils. This will give us a total of 0.3 mils. One thing I like to do is to cancel out all of my zeros, because that just means that I'm punching less numbers into the calculator, less likely to make a mistake. So I just reduce it down. I get the same answer, but I'm less likely to make a mistake. So if that makes sense to you, I encourage you to try it. In our second problem, our nurse has an order to infuse 1,000 mils of normal saline with 10 mil equivalents of potassium chloride in 480 minutes. At what rate should that nurse set the IV pump? We're looking for mils per hour. This would be a good place to pause if you would like to try to solve this problem on your own before I work it out. For this problem, what we have ordered, what we're looking for, our desired, is going to be our hourly rate. How much goes in an hour? So a better way to write this would be 60 minutes, because there's 60 minutes in 1 hour. So 60 minutes, our desired, is going to go over what we have. And so then how many minutes do we have? We have 480 minutes. So we're going to put 60 minutes over 480 minutes. And then we're going to multiply that by our volume or our quantity, which is 1,000 mils. Our minutes cancel out here, and then when we punch that into the calculator, we're going to get 125 mils per hour. So again, I just want to stress, you can reduce this down so that you're not punching so many numbers into the calculator. So 60 over 480 reduces down to 1 over 8. In this problem, we have a client who is MPO with an order for 1,500 mils of D5W 0.45% normal saline with 30 mil equivalents of potassium to be infused over 14 hours. How many mils per hour should the IV pump be programmed for? This would be a good place to pause if you would like to try and solve this problem on your own before I work it out. Since what we have is hours, we're going to leave this one in hours. So our ordered is 1 hour. What we're desiring here is 1 hour. So we will put 1 hour, our desired or our ordered, over our have, which is 14 hours. Next, we are going to multiply this by our quantity or volume, which is 1,500 mils. When we punch this into our calculator, we are going to get a total of 107.14285.7. For this problem, we are going to round to the whole number. What I will advise you to do is follow the directions given to you for each individual problem. It will tell you exactly where to round to. We are rounding to 107 because it is the nearest whole number. When we look at the tenths place, if it is between 0 and 4, we're going to round down. If it's 5 or greater, we will round up. Rounding to the whole number, we are going to end up with 107 mils per hour. Problem number 4, the client is scheduled to receive cephalexin 4 grams in 150 mils of D5W. According to the pharmacy, this preparation should be infused over 90 minutes. Calculate the correct flow rate for this medication. We are looking for mils per hour. This would be a good place to pause if you would like to try and solve this problem on your own before I work it out. So our ordered or our desired for this problem is going to be that 1 hour. And again, this one is going to be in minutes. So 1 hour is 60 minutes. So 60 minutes is going to go on top there. We are going to put that over our have, and we have 90 minutes. We will then multiply by our quantity or volume, which is 150 mils. When we put this into the calculator, we are going to end up with 100 mils per hour. Just to show you what reducing down would look like for this problem, our zeros cancel out. 6 and 9 are both factors of 3. 3 goes into 6 2 times. 3 goes into 9 3 times. And then 3 goes into 150 50 times. So we end up with 2 times 50 divided by 1. Again, we get the same answer, just less numbers to deal with when we're punching it into the calculator. For problem number 5, we have a nurse that is preparing to infuse 1,000 mils of 0.9% sodium chloride IV over 10 hours with a tubing set that delivers 20 drops per mil. The nurse should infuse the IV fluid at how many drops per minute? I want to stress that this method is not the best method to use for IV drip rates and actually takes 3 steps to solve. I encourage you to watch the IV calculations video in your math module in Canvas. This would be a good place to pause if you would like to try and solve this problem on your own before I work it out. So the first thing I'm going to do is look at something where I have an order for something and I have something. So I have an order for 1,000 mils, and then I know that I have 1 mil. So my ordered 1,000 mils is going to be over my have 1 mil. And then we are going to multiply that times our quantity or our amount. So we know that we have a quantity of 20 drops per mil. This will give me 20,000 drops. Now I'm going to find my next ordered or desired. In this case, it's going to be 10 hours. I know that I want this to go over 10 hours. I know that I have 1 hour in 60 minutes. This comes out to 600 minutes. So the last part of this is finding that final desired or ordered. So that final one is going to be 1 minute because I want to know how many drops per 1 minute. So 1 minute is going to be my ordered. And then I know that I have 600 minutes. So I have 1 minute over 600 minutes. And I'm going to multiply that times my quantity, which is going to be 20,000 drops. When I put this into the calculator, it comes out to 33.3333 repeating. Reducing down here, our zeros cancel out, and then we have 6 and 200. They're both factors of 2. 2 goes into 6 3 times, 2 goes into 200 100 times. we end up with the same answer. And we are going to round to the whole number because we can't have a fraction of a drop. So our answer is 33 drops per minute. For our final problem, we have a physician order for digoxin 0.25 milligrams IV every morning. The available vial reads 0.5 milligrams in 1 ml. The nurse would administer how many mils? This would be a good place to pause if you would like to try and solve this problem on your own before I work it out. My ordered or desired is 0.25 milligrams. So I'll have 0.25 milligrams over my have, which is 0.5 milligrams. And then I will multiply this times my amount or quantity, which is 1 milliliter. And I will end up with an answer of 0.5 milliliters. Thank you for completing this video. Please be sure to take the post-module quiz.